we're going to determine where 4x squared plus y squared minus 8x plus 4y plus 4 equals 0 has a vertical tangent line or a horizontal tangent line. First of all, this implicit function is actually something that you saw last year in pre-calc. We'll talk a little bit more about that later. For a vertical tangent, the slope has to be undefined. For a horizontal tangent, the slope has to be 0. Either way, we need our slope, we need our derivative. So take a moment, go find your derivative of this implicit function. There's nothing new there, so I'm just going to work through this, and you try this as well. I think I'm going to keep the dy dx terms on the left and move everything else to the right. And I'm getting a derivative of 8 minus 8x over 2y plus 4. So now going on to our problem of finding vertical and horizontal tangents. Horizontal tangents and vertical tangents. Horizontal tangents occur when our slope, or our derivative, is 0. So I want dy dx to equal 0. For a fraction to equal 0, that means the numerator has to equal 0. So I'm going to say 8 minus 8x equals 0. I'm going to solve. 8 equals 8x, divide by 8. X is going to end up equaling 1. I do want to be able to do a little bit better than this, though. I want to find the entire coordinates. So just like in the last problem, now that I have an x, I can plug that into my original implicit function and find my y. I'm going to get 4 times 1 squared plus y squared minus 8 times 1 plus 4y plus 4 equals 0. 4 plus y squared minus 8 plus 4y plus 4 equals 0. The 4's cancel with the 8. I think I'm going to move up a little bit so you can see that part better. We're going to get y squared plus 4y equals 0. Y times y plus 4 equals 0. Y is going to equal 0 or negative 4. So we're going to get 1, 0, and we're going to get 1, negative 4. I have two places where I have horizontal tangents, 1, 0, and 1, negative 4. Vertical tangents occur when the derivative is undefined. And for a fraction to be undefined, that means the denominator has to equal 0. So 2y plus 4 equals 0. We're going to get 2y equals negative 4, y equals negative 2. So the rest of the work is the same that we did with the horizontal tangents. You can go plug y equals negative 2 into the original, solve for x, and we'll get our points. The 4's cancel with the 8, so I'm getting 4x squared minus 8x equals 0. Again, I can solve this by taking out the GCF. I'm getting 0 and 2, which means I have vertical tangents at 0, comma, negative 2, and 2, comma, negative 2. Horizontal tangents at 1, 0, and 1, negative 4. Vertical tangents at 0, negative 2, 2, negative 2. If we go back to that original implicit function, you might remember this from the conic section unit of pre-calc, where you did circles, ellipses, hyperbolas, parabolas. This happens to be an ellipse. You can turn it into standard form by completing the square. But our ellipse will actually end up looking something like this. And if we look at 1, 0, yep, looks like a horizontal tangent there. And 1, -4 looks like a horizontal tangent there. And vertical tangents at 0, -2, and 2, -2.